This roadmap outlines the skills you need to learn in order to become a senior full-stack developer and secure a six-figure tech job. To make it easier to follow, there are timestamps for each section discussed in the video, which you can find below. And if you're interested in reaching the mid-level position, then make sure to check out the previous parts of this roadmap. Let's start with the AI tools that will enhance your development process. I intentionally didn't mention these tools at the beginning because it's important for you to have solid foundation in web development principles, and relying too much on AI early on can divert the learning process. However, once you're comfortable with the basics and have some experience, AI tools can really boost your productivity. So let's explore some of the AI tools that I think are very useful for developers. The first one is GitHub Copilot, which is a code completion tool that acts like a pair programmer. It uses the context from the code you're writing to suggest whole lines or entire functions, and it's powered by a machine learning model, which is mostly trained on the open source code available on GitHub. I find it useful for quickly generating boilerplate code or the code that you're about to write, or writing some unit and integration tests with it. And with the new updates of the GitHub Copilot, you can now also have Copilot chat integrated into your favorite terminal's side panel and ask questions to it without leaving the code editor. And this can significantly speed up your workflow, but be mindful to review the suggestions it provides because it might not be accurate all the times. The next one is Cursor AI, which also provides the side panel chat as Copilot, but with more focus on your codebase context. It uses machine learning to understand code bases and provides you with the insights that would otherwise require you a lot of time of manual searching and reading. For example, you can clone a whole new repo and ask Cursor AI the steps to run this project, or ask where a certain functionality logic is located, and it will point you to the exact file without you manually searching for it. You can also ask it to apply the suggestions in the code, and it will go ahead and automatically apply its suggested changes, and then you can decide if you accept it or you want to modify them. I personally find the Cursor AI more useful and accurate than GitHub Copilot's chat, especially in code-based related questions, but I still use the GitHub Copilot for quick code suggestions. The next one is not a tool but a skill that will be beneficial if you learn it, and is prompt engineering, which is becoming more and more important with all of these AI tool rises. All of these interactions that you have with Copilot, Cursor AI, and other AI tools can be as good as your prompted skills are. If you're able to communicate effectively with the AI tool, then you will get the answers you are searching for, and the way you ask questions or frame tasks can make the significant difference in the quality of the output you will get. I highly recommend taking a short course on prompt engineering to learn these techniques, which will save you a lot of time down the line in your career and day-to-day tasks. Then we of course have everyday tools like ChatGPT, Gemini, or Microsoft Bing. I'm sure you at least know ChatGPT, which is a conversational AI tool designed to assist with a wide range of tasks. And you can use it for coding assistance and even for educational purposes on a topic that you'd like to learn. I also used Microsoft Bing because it does the web searches and links to the resources it finds, but after OpenAI integrated the web browsing feature in ChatGPT, now I just use ChatGPT and it does the web searches when needed. But still, it's important to keep an eye on all of them because, for example, Google's first AI model, which was called BART, was very weak compared to GPT model, and because of that, they had to shut it down. But now they came up with Gemini AI, which seems a lot more promising, and it may become better than GPT model. So keep an open mind here and use the one that helps you better with your tasks. If you can afford it, I definitely recommend the GPT Pro or Gemini's Pro versions. It will be 10 times better than the free model. Then we have Agent GBT and God Mode tools, which are virtual agents that can perform tasks on your behalf using natural language processing. This leverages the capabilities of advanced language models like GBT to interpret and execute commands given in the natural language. For example, you can create a developer agent and task it with a big feature that you need to implement, and then it will break down your large goal into small and manageable parts which you can start implementing. LangChain is an open source library that can be integrated inside of an application. It allows developers to incorporate large language models such as ChatGPT into workflows that involve tasks such as searching web or querying databases or calling APIs. So LangChain extends the functionality of a language model beyond simple text generation. And AutoGPT is available on GitHub, and it's a project that automates interactions with OpenAI's GPT models. With this tool, developers can more easily create bots and other automated systems that utilize GPT. I even tried it for bug fixing and assigned it to a task to fix a bug, but it didn't perform very well at that time. But definitely keep an eye on this because it might get better over time. You can choose which ones of these tools help you most in your day-to-day coding tasks and start using them. The most important part when using all of these tools is your prompting techniques. The better you can describe what you need, the better results you will get out of these AI tools. The next area is data structures and algorithms. And some people start with this first before even working in a job, but I think that doesn't make sense as you don't really understand where this can be used unless you work on real projects. So I would learn this after working on at least one developer role. These are important for you to understand deeper of how software works and for solving complex problems effectively. Here you will learn about BIGO time and space complexities. BIGO notation is what describes the time and space complexity of an algorithm. It's just a way for us to describe the efficiency of an algorithm, and is important for understanding the potential performance bottlenecks and how to improve our algorithms. You'll learn about traversing, which is the process of visiting all the nodes or elements in a data structure, such as arrays, trees, or graphs, to perform some operations on them. The simplest example is just a for loop on arrays. In trees and graphs, traversal is more complex, and that is depth first search and breadth first search, which we'll get into in a second. You'll learn about recursion, in other words, a function that calls itself as a subroutine, and this allows for solutions to problems to be expressed in terms of one or more smaller instances of the same problem, meaning one or more sub-problems of the same problem. You'll learn about sorting data in a particular order and about common sorting algorithms like quicksort, merge sort, bubble sort, and others. The other important part of data structures is trees and graphs. These are hierarchical data structures that represent relationships, and in fact, trees are just a special case of graphs with no cycles in them. Here you also see that we have depth first search and breadth first search, which are just the traversal algorithms on trees and graphs. In case of DFS, we use a recursive algorithm, and in case of BFS, we use an iterative algorithm, but they are basically doing the same, which is traversing over a tree, just in a tiny different ways. And lastly, we have dynamic programming. It's an optimization technique used to solve complex problems by breaking them down into simpler sub-problems, and it is used when the sub-problems are not independent, meaning when sub-problems can overlap. And dynamic programming solutions are usually implemented using recursion and memoization, which means storing results of expensive function calls and then not doing them in the next time. And by learning this, you will practice your problem solving skills, but these also come up in technical interviews for software development positions, and that can be useful for you to pass the interview. The next important aspect to learn is software testing. By writing tests, you can ensure that the code meets the required quality standards, and these tests can help us catch the bugs before even the end user encounters them by running them in CI/CD pipelines and checking them before each deployment. The simplest way of testing is by writing unit and integration tests. Unit testing means testing the individual components or functions in isolation from the rest of the application. And the integration tests ensure the connection between components, processes, and systems. So unit tests are for ensuring that each part works properly on its own, and integration tests is to detect any inconsistencies between the units that have been integrated. Common tools for testing in web development are the Jest, Mocha, and Chai frameworks. Jest is probably the most popular one, and it's well known for its zero configuration approach to unit testing, whereas Mocha and Chai provide a more flexible framework and assertion library. TDD stands for test-driven development, which is an approach where the test is written even before the code is implemented. So the cycle of TDD is to first write the test, run it, and it should fail since there is no implementation yet, and then write the code to pass these tests and then refactor as necessary. E2E stands for end-to-end testing, and this kind of tests can test the whole flow of the application. It aims to replicate real user scenarios so that the system can be validated for integration and data integrity. For example, it can go ahead and log into your website and perform some actions that users typically perform and test the whole flow and catch any bugs that may appear there. And Cypress is just one of the popular tools for writing end-to-end tests. And API testing is where we test the endpoints of our APIs and expect for the outputs. This usually involves testing the functionality and reliability of APIs, and Postman is one of the tools that can be used for testing APIs. Performance testing is also typically ran against APIs, but this is a different kind of test used to determine how a system performs in terms of responsiveness and stability under a certain load. So with performance tests, we are checking how our API behaves under stress and peak conditions with many traffic and users. And this can include load testing, stress testing, and more. So this part is mainly for us developers and it doesn't affect the end users. It's just for us to test and validate our code and find any bugs before they reach to our end users. Then we get to design patterns, which are solutions to commonly occurring problems in software development, just like templates that can be applied to real-world coding situations. There are many more design patterns than I listed here, but these are the most popular ones. For example, the singleton pattern ensures the class has only one instance and provides a global point of access to it. It's useful for things like managing a connection to a database or file system, or for having a centralized logger inside of our application. Then we have the factory pattern, which is used to create objects without specifying the exact class of object that will be created. So it just creates objects in a superclass but allows subclasses to alter the type of objects that will be created. In dependency injection, the object receives other objects that it depends on, and these other objects are called dependencies. So using this pattern, we reduce the hard-coded dependencies and make it easier to change the application's parts without affecting others. Proxy pattern provides a placeholder for another object to control the access to it. This is also useful for logging, and it could also act as an intermediary in network requests, for example. In scenarios where we have a complex subsystems, we use the facade pattern. This doesn't encapsulate the subsystem, but it provides a simplified API to clients, which can make a subsystem easier to use or decouple the subsystem for our clients. The observer pattern defines one-to-many dependency between objects so that when the object changes its state, all of its dependents are notified and updated automatically. And the iterator pattern is useful when we want to traverse collections such as lists, trees, and graphs. So these design patterns usually improve the readability of our code because they are also known by other developers that you'll be working with. And the last important step is system design concepts. These concepts are important for designing systems that meet modern performance and reliability standards. And these are the most important and foundational components of system design. We have the networking part, which includes understanding TCP, UDP, and DNS. TCP and UDP are protocols. TCP is a connection-oriented protocol that ensures reliable, ordered, and error-checked delivery of data over a network. UDP is a more simpler protocol, but it doesn't guarantee delivery order or error checking. Therefore, it's faster and more efficient for applications that don't need TCP's guarantees. For example, live streaming or video chatting applications, where some loss of data is acceptable. Then we have monorepos, which is a single repository that stores all of our code and assets for every project. The benefits of this is to simplify dependency management, refactoring, and understanding codebase history because it's all visible in one place. And this is not something that is used by small to medium companies. Even Google nowadays uses a monorepo for most of its codebase. And TurboRepo and Lerna are just examples of the tools that help us create these monorepos. Then we get to the API design part. And when designing APIs, we typically choose between microservice and monolithic architectures, and also messaging architectures or standard communication. The microservice architecture consists of small autonomous services that work together. Each service here is self-contained and implements a single business capability. For example, one service can implement an authentication logic, Another service can implement the payment logic, and so on. Monolithic architecture is the traditional way we use to build apps. Here all of the components are interconnected and they usually live in the same big software. In case of messaging architecture, these components are communicating through message queues, and some of the popular message queues are AWS's SQS, Kafka, and RabbitMQ. These are used to handle asynchronous data flow and improve scalability and fault tolerance. Next important part is caching and CDNs. Caching stores copies of data in temporary storage to serve requests more quickly in the next time. And CDNs are another type of caching, but in distributed networks of servers that deliver content to its users based on their geographical locations. So this means that people in US, for example, will get the content from the US server, and people in Europe will get the content from Europe server, which will improve the speed of the website and application. Then we have data replication and sharding, which is mostly referring to SQL databases. Data replication is copying data from one location to another to increase readability and accessibility. For example, having one leader database and multiple follower databases so that the API can access these follower databases when it just needs to read data. And sharding is a type of database partitioning that separates the large databases into smaller ones. This is usually more complex than data replication, and you usually won't need this in case of NoSQL databases. Then we have object storage, which is for storing large data. It is also called blob, which stands for binary large object. It's a collection of binary data stored as single entity in database system as key value pairs. Proxy servers are another important part of system design. The most popular ones are forward and reverse proxies. Forward proxy sits between a client and the internet, and it's used for keeping the anonymity of user or caching purposes. And reverse proxy, on the other hand, sits in front of web servers and forwards client requests to those web servers. And in this case, we can keep the anonymity of the web servers. Load balancers are the most popular use cases of reverse proxies. We use them to distribute network or application traffic across a number of servers to ensure that no single server bears too much load. And the last part of system design concepts is improving the performance of our web app, which includes front-end, back-end, and network performance parts. Front-end performance relates to how quickly content is rendered in the user's browser. This is typically referring to the critical render path and how we are displaying our first web page to the user. Backend performance involves the server-side operation speed and efficiency in processing these client requests. And the network performance refers to the measures of service quality of the network, including the throughput, latency, and the uptime of our servers. And putting all these concepts together, you can now design and create a scalable and robust software architectures. These concepts are typically part of the interview for senior roles, along with data structures and algorithm. And by mastering the concepts outlined in this roadmap, you can position yourself as a strong candidate for senior full-stack developer roles, and these roles offer the potential to earn six-figure salary regardless of your location, because there are a lot of remote opportunities nowadays. Of course, learning doesn't stop here. The landscape is constantly evolving with new tools, technologies, and best practices, and it's important to keep up with these changes to remain relevant in the industry. Additionally, you can always revisit and refine the core concepts or learn some new languages and tools. Thanks for watching, and if you're interested in learning about the tools and technologies that have been outlined in this roadmap, then consider subscribing for my upcoming videos.